Good morning. Let me welcome you to my third educational video on indices. This particular chapter deals with this particular presentation deals with some of the difficult problems maybe involving all the applications of indices. Here we have some of such examples taken from your previous question papers. Let me remind you some of the basic laws. You have learned about all these laws already in my previous session. Let me explain you one by one. Just remind you, a power 0 is 1, a power m multiplied a power n is equal to a power m plus n. A power m divided by n is a power m minus n, where m is more than 1. If m is less than 1, this becomes n minus m. That's it. A power n is a power mn. A power minus m is equal to 1 divided by a to the power of plus m. This is sixth law. Nth root of a is equal to a to the power of 1 by n. This is the problem taken from your previous question paper. It says that 7 into root of x square into 5 root of x square, x to the power of minus 2 by 7 into root of y divided by y to the power of minus half, all denominator I am telling about, 3 into root of y square, 3 into root of y, and x to the power of minus 2 by 5. You can read it as 7 root of x square whole divided by y root of y to the power of minus half, and 5 root of x square divided by 3 root of y square into x to the power of minus 2 by 7 divided by 3 into root of y into root of y divided by x to the power of minus 2 by 5. This is what the problem is. And if you apply the sixth law, nth root of a, this nth root of a says that a to the power of 1 by n. This is what the law is, sixth law. Nth root of a is equal to a to the power of 1 by n. Going with the same law, I can write the numerator as 7 into x to the power of 2 whole to the power of 1 by 2, where this root is replaced as 1 by 2. The square root is 1 by n. Apply the formula, that becomes 1 by 2. Similarly, you retain this uh, y to the power of minus 1 by 2, and otherwise you can take this as y to the power of plus half or root of y. That can be done, but anyway I am retaining this. Now 5 into root of x square, that is 5x square to the power of 1 by 2. 5x square to the power of 1 by 2. This 1 by 2 is because of root. X to the power of minus 2 by 7 and y to the power of 1 by 2. This 1 minus 1 by 2 is retained, and 3 into y square to the power of 1 by 2. Again 3 into y to the power of half, x to the power of minus 2 by 5. And this becomes 7 into x to the power of 2 by 2, 5 into x to the power of 2 by 2, x to the power of minus 2 by 7, y to the power of 1 by 2. This 2 by 2 is 2 into 1 by 2, again 2 into 1 by 2, that becomes 2 by 2. Now this is y to the power of minus 1 by 2. Now 3y to the power of 2 by 2, 3y to the power of half, and x to the power of minus 2 by 5. Now 7x, 5x, 2 by 2 is 1. Now x to the power of minus 2 by 7. And if you say this, y to the power of 1 by 2, you can retain as it is, or you can move this to downside, anything that you can do. But for the time being, I am placing this y to the power of 1 by 2 as it is. No change in that. Now, if I multiply the constants, this becomes 7 into 5, that is 35. And now if you take all x powers together, x to the power of 1 and x to the power of minus 2 by 2, and here we have one more x to the power of 1. This becomes x to the power of 1 plus 1 plus minus 2 by 7, and this y to the power of 1 by 2 retained as it is. Now 1 into 3 into 3, this is 3 3, and coefficients are multiplied, all coefficients are multiplied, and this is y to the power of 1, y to the power of half, and again here is 1 minus half, plus half 1 minus half, you can cancel it. I am applying the formula a to the power of m into a to the power of n is equal to a to the power of m plus n. Now if you go to this x to the power of minus 2 by 5, you can retain as it is. The 7 into 5 is 35, and x to the power of plus 1 and plus 1, it is 2 minus 2 by 7, and you can take LCM to simplify this, and y to the power of 1 by 2. And now this is 3 into 3 is 9, and minus 1 by 2 plus 1 by 2, this is uh, you can cancel this, and y 9 y to the power of 1 and x to the power of minus 2 by 5. And further if you simplify, this becomes 2 minus 2 by 7, take 7 LCM, 14 minus 2, this becomes 12, 35 x to the power of 12 by 7 and y to the power of half. Now denominator becomes 9 x to the power of minus 2 by 5 and y to the power of 1. This is 35 x to the power of 12 by 7 into y to the power of half, and 9 x to the power of minus 2 by 5 into y. This is 35 x to the power of 12 by 7 y to the power of half, and divided by 9 x to the power of minus 2 by 5 and y. 35 by 9 you can take common. Now this x to the power of minus 2y, you can put it in the numerator, that becomes 12 by 7 plus 2 by 5, and y to the power of half here, and you can take this plus 1 to the upper side, that becomes minus 1. This is 35 divided by 9 x to the power of, if you take LCM, 7 and 5 LCM is 35, and this is 12 5s and 2 7s, 60 plus 7 14, 74, this becomes 74, 35. 35 by 9 x to the power of 74 divided by 35, and this is y to the power of 1 by 2 minus 1, and LCM is 2, 1 minus 2 is 2, that becomes minus 1 by 2. The final answer is 35 divided by 9 into x to the power of 74 divided by 35 into y to the power of minus half. The final answer is 35 divided by 9 x to the power of 74 by 35 into y to the power of minus half. This is what exactly the solution or the simplified form of the given 7 root of x square divided by y to the power of minus half, 5 root of x square divided by 3 root of y square into x to the power of minus 2 by 7 divided by 3 root of y into root of y divided by x to the power of minus 2 by 5. The simplified form is this one, 35 divided by 9 x to the power of 74 by 35 into y to the power of minus half. Okay, let me go for the second one. The second one says that the second problem, 4 x to the power of 2 whole to the power of 3 divided by 2 x to the power of 3 whole to the power of 2 plus 6 x to the power of 3 whole to the power of 2 divided by 3 x square whole to the power of 3. Now you can recall the relation a power m whole to the power of n is equal to a to the power of mn. If I apply this relation here, you will get it as this is 4 to the power of 3, again x to the power of 2 whole to the power of 3. This is, you can say, ab to the power of ab to the power of m. If you say a to the power of m, b to the power of b to the power of m, ab to the power of ab to the power of m is equal to a to the power of m b to the power of m. This becomes 4 to the power of 3 x to the power of 2 whole to the power of 3. That is x to the power of a power m to the power of n is equal to a power mn. This becomes 4 cube x to the power of 6 divided by 2 power 2 x to the power of 3 2 is 6. Now 6 to the power of 2 x to the power of 3 whole to the power of 2. Applying the relation ab to the power of m, this is equal to a to the power of m into b to the power of m. This, that particular law is not added here. You can take it as seventh law of indices as a b to the power of m is equal to a to the power of m into b to the power of m. Now if you apply the relation continue for the sum here, this is x to the power of 2, this is x to the power of 3 whole power 2, this becomes x to the power of 6. Similarly 2 power 2 x to the power of 3 whole power 2, 3 power 3 x to the power of 2 whole power 3, this is 4 power 3 x to the power of 6. Now this is 2 power 2 and x to the power of 6. 3 2 is a power m to the power of n is equal to a to the power of mn. This is what exactly the law I'm speaking about. A power m to the power of n is equal to a to the power of mn. X to the power of 3 whole to the power of 2 is equal to x to the power of 3 into 2. That's what exactly I have applied here. Okay, next similarly, okay, if I go for this 4 power 3, 4 pi, you can simplify directly taking 4 power 3 as 64, or as we have 2 in the denominator and 3 again, one more denominator is there, you can convert all 4 bases into its 2. That is having equal kind of bases so that we can have the easy simplification. Now 4 can be written as 2 power 2, 2 power 2 whole power 3. Again, this is 6 can be written as 2 into 3 to the power of 2. You can remember me my instruction. When you are simplifying laws of indices, convert the bases into its prime numbers. You say the prime number basis. Okay, maybe this is 2, 3, 5, 7, 11, like that. You have this prime number basis, it will be AC, very easy to simplify. Now this is what exactly the 4 and 6 are converted into its prime number basis. The prime number basis, if you say, now here 2 power 2 whole power 3, if you say 2 power 2 whole power 3, this becomes 2 power 6. Now again here 2 power 2 into 3 to the power of 2, this becomes 2 power 2 into 3 power 2. Now this is, we have 2 power 2 in the denominator, this becomes 2 power 6 divided by 2 power 2, that becomes 2 power 6 minus 2. Again x power 6 and x power 6, either you can cancel it directly or you can apply the formula a power m to the power of n is equal to a to the power of m by n This is equal to a to the power of m minus n. Now this is 2 into 3 to the power of 2. This is 2 square and 3 square x to the power of 6. Now here I can have this constants one side, 2 square and 3 square, and again for 3 power 3, 3 square minus 3 power 2 minus 3. This is 3 by 3 power 2 divided by 3 power 3. This becomes 3 power 2 minus 3, uh, sorry, 3 power 2 divided by 3 power 3. That becomes 3 to the power of 2 minus 3, m by n formula. And here numerator power is more and the denominator power is less. And anyway, you get the sign into effect. Therefore, you need not to worry much. That is x to the power of 6 per 6. That is x to the power of 6 minus 6 is 0. Now, 2 to the power of 6 minus 2 is equal to 4. X to the power of 6 minus 6, that is 0. That is 1. Anything raised to the power of 0 is equal to 1. That law is also there. Okay, look at this. This is what the law is. X to the power a to the power of 0 is equal to 1. Now here x to the power of 0, 6 minus 6 is 0, that is equal to 1. Now 2 power 2 into 3 to the power of 2 minus 3, that is 3 to the power of minus 1. Now x to the power of 6 minus 6 is 0. Now this is 2 power 4 is 16 and 2 power 2 is 4. Now the answer is 16 plus 4 into 3 to the power of minus 1. 16 plus 4 divided by 3. A to the power of minus m can be written as a to the power of plus 1 by a to the power of plus m. And now 3 power minus 1 you can take here, it becomes denominator, if it goes it becomes a to the power of plus 1. 16 plus 4 by 3, take the LCM, 3 as LCM. Now 16 3s are 48 plus 4 50, 52 divided by 3. The final answer is this, 16 plus 4 by 3. You can take the LCM and simplify. This is 52 divided by 3. Okay, I'm using a different kind of relation here, that is AB to the power of m is equal to a to the power of m into b to the power of m. The power is to be applied for two or more of the factors which are there in your base. That's what the law says. And ultimately applying that particular law of ab to the power of m, as well as here a power 0 is equal to 1 and a power m by a power n, a to the power of m minus n formula, I am deriving this relation as 52 divided by 3. Let me go for one more, the second one. I'm sorry, the third one. Okay, it is again taken from your question paper. Okay, I think this is from 2014 question paper, that is 10 to the power of m plus n into 12 to the power of 2m minus n into 25 to the power of n divided by 18 to the power of m minus n, 15 to the power of m plus 3n into 16m. We can remember the thumb rule. Whenever you have the bases as large numbers, okay, maybe I can call it as 2 digits. You can convert all these 2 digits numbers into their prime bases. Okay, not exactly 2 digits, but see that okay, the bases are bit larger numbers. Okay, say 10, I can convert that into its prime number basis. I have converted 10 as 2 into 5 and 12 as 3 into 2 into 2 or 3 into 4. Now 25 as 5 into 5. 18 I can convert as 3 into 3 into 2. 15 3 into 5. 16 2 into 2 into 2, that is 2 to the power of 4. Here the thumb rule that is to be followed is that whenever you have such kind of no basis, see that whether the bases are there in their prime number form. Prime number form. If we say the prime number form, all the bases should be in their prime number values. Here 10 is not a prime number, but 10 can be written as the factors of prime numbers. 12, of course, it's not a prime number, but that can be factorized to have its prime numbers. 25, again the same thing. Similarly, applying that thumb rule, I can convert this as, okay, 2 into 5 to the power of m plus n, 3 into 4, that 4 is written as 2 to the power of 2. Okay, now 2 to the power of m minus n, and 25, 5 square to the power of n. Now 18, 3 to the power of 2 into 2 to the power of m minus n. This is 9, I have written as 3 square. Now 15, 3 into 5, m to the power of m plus 3n. Now 16, 16 can be written as 2 to the power of 4 to the power of m. Now applying the appropriate relation, I can write it as, here see, ab to the power of m. You can take the complete power. Here m is nothing but m plus n. 2 to the power of m plus n, 5 to the power of m plus n, 3 to the power of 2m minus n. Now 2 to the power of 2 multiplied with this power 2m minus n, that is 2 into 2, 4m minus 2n. Now 5 to the power of 2n. Now this is 3 to the power of 2 multiplied with m minus n, that is 2m minus 2n. Again 2 to the power of, look at this, m minus n. 3 into 5, again say 3 to the power of m plus 3n, and 5 to the power of m plus 3n, 2 to the power of 4m. Okay, and we are having a lot many m and n values. Be careful. Okay, take all m one side, all n one side, and even try to have the common basis, identical basis, and then it is easy for us to simplify. 2 to the power of, this is m plus n. Again, where is you have one more 2 base here, 2 to the power of 4m minus 2n. Look at this, 2 to the power of m plus n, again plus 4m minus 2n, 4m minus 2n. Similarly, 5 to the power of m plus n, here 2n is there, m plus n plus 2n. Now 3 to the power of 2m minus n, as it is. This 2 power 4m minus 2n is combined here, and numerator is simplified. Now this is 3 to the power of 2m minus 2n. Now this m plus 3n is added here, m plus 3n is added here. Now 2 to the power of m minus n, it is taken here, and 2 to the power of 4m, m minus n plus 4m. Look at this, I have applied a to the power of n into a to the power of m is equal to a to the power of m plus n formula. Now 5 to the power of m plus 3n. Look at this, 5 to the power of m plus 3 is applied, and now all identical bases are segregated ones, segregated in one bunch. Now if you simplify this becomes m plus 4m is 5m, n minus 2n is minus n. Yeah, 5 to the power of m plus n plus 2n, this becomes m plus 3n, and 3 to the power of 2m minus n. Now 3 to the power of 2m plus m is 3n, minus 2n plus 3n is plus n. This is 3n plus sign is there. Okay, highest number is 3, therefore you can retain this. Now 5 to the power of m plus 3n, 2 to the power of this is 5m minus n. This is 2 to the power of, and you can take this 4m plus 1m, 5m minus n, 5m minus n. 5 to the power of m plus 3n as it is, and now 2 I have taken here. Now taking say if you look at this, we have the basis as 253, again 253. Now 2 to the power of 5m minus n here, and we have 5m minus n, and we can take it to numerator, that becomes minus of 5m minus n. Now 5 to the power of m plus 3n and minus m plus 3n. 5 to the power of m plus 3n. Okay, maybe there is some correction here. M plus, this is m plus 3n. Now 3 to the power of 2m minus n, 2 to the power of minus 5m minus n. Look at this 2 here. Now 5m minus n, and this is 5m minus n. Next 5 m plus 3n, and again this is m plus 3n, this is m. Now 3 to the power of 2m minus n, this is minus 3m plus n, here is minus of 3m plus n. Now if you go on simplifying this, ultimately you can get, okay, 2 to the power of 5m minus n minus 5m plus n, and you are going to cancel this 5m and minus 5m plus n minus n plus 3m, and okay, this is plus m plus 3n minus 3n, okay, it is cancelled, plus 3n and minus 3n is cancelled, and 5 to the power of 0, if you say this, plus 3n is here, and because it's minus, it is going to minus 3n, and uh, you're going to get this as 5 to the power of 0. Now 3 to the power of 2m minus n minus 3m minus 2n, minus n, 3 to the power of minus m, 2m minus 3m is minus m, minus n is minus 2n. Now this is to the power of 0 into 5 to the power of 0, and this becomes 1. 3 to the power of minus m minus 2n. The final answer is 3 to the power of minus m minus 2n. This is what exactly the proof that we are looking for. This is again I said question paper problem. This is what the proof is, and the problem is a bit lengthy, and there's a lot of chance you to get confused, and you to take values in a different sense and understand the values in a different way, and there's a way to commit mistake. And be careful while segregating these powers, as well as classifying the powers into their identical ones. And this particular step exactly, you need to be very careful this step, and after that, okay, it's all about, okay, simple arrangement, 3 to the power of minus m minus 2n. That's it for today. Thank you very much. I'll explain you a few more problems in my next video. Thank you very much.